Okay, for the last section for test 2, we're going to look at variation problems. And certain relationships occur so frequently in applied situations that they are given special names. So variation equations generally show how one quantity changes in relation to other quantities. The relationship between the quantities can be described as direct, inverse, or joint variation. So the first type we're going to look at is direct variation. And this is going to be in the form of y varies directly as x, or y is directly proportional to x. So those basically mean the same thing. And we're going to find where you see the word varies, we're always going to be inserting equals k, which is the constant of variation. So for direct variation, our equation is going to be in the form y equals kx, where k is the constant of variation, or the constant of proportionality, and y and x are the things that are related. Alright, so these first couple of examples, we're just kind of getting used to what this stuff looks like. So if y varies directly as x, given y equals 24 when x equals 6, it wants us to find the constant of variation k and the variation equation. So we're going to follow pretty much the same steps for all of these. Remember, for y varies directly, it's y. When we see varies, we're going to write equals k. And then depending on the type of variation, this one is directly, the only one that we've learned so far. Directly means that we multiply k times that variable. So directly as x means that we're just going to multiply k times x. So given this y equals kx, if I know y is 24 when x is 6, we can substitute these values and solve for k. So I'm going to substitute 24 in the place of y. We don't know k, that's what we're going to be solving for. And for x, I'm going to substitute 6. So this is just basically 24 equals 6k. That's just rearranging it in the order we're accustomed to looking at it. And if I want to solve that for k, this is just 6 times k, so we'll divide both sides by 6, and I get k equals to 4. So this is the first answer they're looking for. The constant of variation for this problem is k equals 4. Now that we know what k is, we can substitute that back into our original variation equation, which was y equals kx, and that will answer the second part. So all we're going to do is write y equals. We found out that k is 4, so I'm going to substitute 4 for the k. And now this is my variation equation. All right? For the next one, I have y varies directly as again. So y varies is equals k each time. So varies directly, so we know it's going to multiply with k. And what is varying is the square of x. So that wants x squared. So then we're going to do the same process that we just did in the first one. Given that variation equation, if I know y is 48, we can make that substitution. We don't know k, but we know that x is 8, and don't forget, in this problem, the x is squared. So we get 48 equals k times 64. And then you can write this in the order that we're accustomed to seeing it. Then to solve for k, we just need to divide. So this is going to give me k equals 3/4. And the way I got 48 over 64 equals 3 over 4, I just entered that into the calculator and let it simplify it for me. So this is my constant of variation. So to give the variation equation, we just go back to our original again, and all we're going to do is substitute the value that we found for k. Alright, so let's look at one more of this type. This time I have y varies is equals k again. What it's varying directly as, this time, is the cube root of x. So remember, we write cube root this way. So then we're going to plug in our given values. We know y is 18, so we'll make that substitution. We don't know k, but we know x is 27. So if we simplify this one, the cube root of 27, you can use your calculator to find that. The cube root of 27 is also asking me what do I multiply times itself 3 times to get 27. So that value is 3. So you can write it this way again. To get k by itself, I'm going to divide by 3, and that gives me k equals to 6. So this is my constant of variation. And then lastly, we're going to write the variation equation by substituting back in the value that we got for k. Alright, the last one of these that we're going to look at is an application that we can use with this direct variation. This says Hooke's law states that the distance a spring stretches is directly proportional. And remember, these words directly proportional are exactly the same as the word varies. So that means we're going to write equals k to the weight of the object attached to the spring. This is supposed to say object, sorry. So let's call the distance d. Then we have equals k. And what varies directly is the weight. Let's call that w. So we can write the equation distance varies directly with the weight. So first it tells me if a 3 kilogram weight, so that's giving me a w, attached to the spring stretches it 21 centimeters, so that's a D. We want to find the distance that a 5 kilogram weight will stretch the spring. So this is going to have the same two steps that the above problem had. First, it's giving me a W and a D that I can plug in and solve for K. So a 3 kilogram weight, we're going to put the 3 in the place of the W, and it stretches 21 centimeters, so that's my D. So if we write this in the order we're accustomed to seeing it, I can divide both sides by 3, and I get K equal to 7. Now that I know what that constant of variation is, I can find the distance for a spring that has any amount of weight hooked to it. So I'm going back to my original equation. We're going to find the distance, so we're looking for D. Now I know that K is 7, we just solved for that. And now we have a 5 kilogram weight, so that's going in for W. So that gives me D equals 5 times 7 is 35. And in these problems, my distances are in centimeters. So this distance is 35 centimeters.